Mercury, a planet of extremes. Mercury stands as the nearest neighbor to the Sun in our solar system, a title that might lead one to assume it's indefinitely hot. However, such assumptions can be misleading. By night, temperatures on Mercury can plummet to an astonishing minus 180 degrees Celsius. Daytime presents a stark contrast where temperatures can soar to a blistering 430 degrees Celsius. This profound temperature disparity occurs because Mercury lacks a substantial atmosphere to moderate heat. Instead, it possesses only a very thin exosphere, an atomic-scale envelope that does little to retain warmth. Besides temperature extremes, the weather on Mercury poses no significant threats. The real hazards come from solar radiation and the absence of breathable air. In fact, Mercury is bombarded with nearly 7 times the solar irradiance that the Earth receives. As the smallest planet in the solar system, Mercury's surface is riddled with craters, cliffs, and rugged terrains, creating a challenging environment for any potential landing attempts. Compounding these challenges is the negligible air resistance that would make it difficult for a spacecraft to slow down, thereby increasing the risk of a high-speed impact upon landing. Landing during the day is impractical due to the extreme heat. NASA's state-of-the-art spacesuits can only withstand temperatures up to 121 degrees Celsius, ludicrously inadequate for the daytime conditions on Mercury. With daytime temperatures soaring to 430 degrees Celsius, a standard suit would offer no protection. Nighttime, while cooler, boasts freezing temperatures that can drop to minus 180 degrees Celsius, which still exceeds the lower limit of NASA suits, minus 157 degrees Celsius, resulting in a high likelihood of experiencing frostbite or worse. The most viable option for a safe landing would be the terminator zone, the transitional area between day and night. Here, temperatures can be more moderate, although even in this region, conditions can change quite rapidly. Venus, the sister planet turned hostile. Venus, often termed Earth's sister planet, sits merely 40 million kilometers away. In theory, this proximity might suggest a feasible journey, taking about 4 months to arrive. Moreover, Venus's size and gravity are not drastically different from Earth's, which could provide some comfort. The foremost threat comes, however, at the moment of descent. The striking yellow clouds that capture the eye as one approaches the surface are not as inviting as they appear. They are composed of sulfuric acid, a substance potent enough to disintegrate lung tissue almost instantaneously. Assuming you possess an advanced spacesuit capable of filtering the harmful acidic elements, the situation does not improve significantly as you descend. Visibility diminishes swiftly due to the extremely thick atmosphere, which is predominantly carbon dioxide. This leaves little breathable air and considerably hampers vision. Temperatures at the surface are blisteringly hot, averaging around 450 degrees Celsius, making any prolonged presence virtually impossible. The sunlight reaching the surface is also only about 10% of what it is on Earth. The thick atmosphere serves to block most of it, resulting in dim lighting conditions. Though the gravity on Venus is almost equal to Earth's, the dense air makes moving around akin to wading through molasses. You might last mere seconds with a pressurized suit before succumbing to the crushing atmospheric pressure of approximately 92 bars, compared to Earth's standard pressure of 1 bar at sea level. If the pressure doesn't prove fatal, the sulfuric acid that would breach your suit surely would. Mars, the red planet and its challenges. Mars is the second closest planet to Earth and is frequently deemed the most hospitable among the solar system's planets. Daytime temperatures can reach a more palatable 20 degrees Celsius, but the real difficulty arises during the night when temperatures can plunge to minus 153 degrees Celsius. A significant challenge Mars faces is its extremely thin atmosphere, composed majorly of carbon dioxide, with only trace amounts of oxygen. This deficiency means breathable air is scarce. The thin atmosphere leads to low pressure, making exposure to natural radiation a significant concern. On average, Mars receives radiation levels totaling 24 to 30 rads, about 40 to 50 times that of Earth. Moreover, Mars is known for its violent dust storms, which can generate winds exceeding 100 kilometers per hour. These storms complicate any attempts to establish a stable, habitable environment, necessitating robust, sustainable, airtight life support systems. Jupiter, the giant king of the solar system. As the largest planet in the solar system, Jupiter presents significant challenges for any would-be explorer. One of the foremost concerns is its extreme radiation levels. Even at a distance of 300,000 kilometers, radiation would quickly permeate most protective gear, leading to dire consequences. However, assuming there exists a highly hypothetical suit capable of blocking this radiation, Jupiter's gravity, which is 2.4 times that of Earth's, would make descending through its atmosphere a thrilling experience. Upon entering the initial layers of the atmosphere, adventurers would encounter white clouds composed of frozen ammonia crystals at frigid temperatures around minus 150 degrees Celsius. The wind speeds here, reach astonishing velocities of up to 482 kilometers per hour. If you manage to venture approximately 150 kilometers deeper into the atmosphere, you would reach the most profound point explored by NASA's Galileo probe in 1995. Beyond this point, visibility diminishes, and both temperature and pressure begin to increase rapidly. Fun fact, the pressure near Jupiter's core is estimated to be about 100 million times that of Earth's atmosphere. After hours of descent, one might find themselves in Jupiter's inner layers, where environments shift to a supercritical fluid state, an intriguing intermediary state that is neither gas nor liquid. Continuing deeper, one would encounter metallic hydrogen, an incredibly dense liquid, potentially entrapping any explorer. If one managed to push through further, they may discover Jupiter's core, though expected temperatures are around an astonishing 24,000 degrees Celsius, roughly 4.5 times the temperature found on the surface of the Sun. Saturn. Splendor and danger. Saturn, distinguishing itself as the second largest planet in the solar system, is recognized for its vibrant atmosphere rich in hydrogen and helium. The first obstacle to navigate here would be the vast number of Saturn's orbiting moons, 146 in total. If successful, you would marvel at Saturn's iconic rings, formed from debris, including remnants of ancient moons, ice pellets, comets, and asteroids. As you approach Saturn's equator, a vivid spectacle of red and purple auroras ignites the sky due to high-energy hydrogen in the atmosphere. Unfortunately, this beauty is not without peril. Hurricane-force winds swooping in at speeds reaching approximately 1,800 kilometers per hour would make approaching the planet a daunting challenge. Entering from the North Pole offers no sanctuary, as this region is home to an enormous storm large enough to fit 2 Earths. Here, ammonia clouds, reminiscent of those in Jupiter's atmosphere, prevail, and temperatures can reach an unforgiving minus 250 degrees Celsius. As one ventures deeper through Saturn's layers of clouds, temperatures eventually increase again, climbing to around 0 degrees Celsius. While the brutal cold may begin to lessen, pressure becomes the predominant threat, escalating to levels comparable to the deepest recesses of Earth's oceans. Continuing further down, the gases would transition into a liquid state. If you somehow manage to survive the arduous journey to Saturn's center, you would find yourself face to face with a molten rocky core that dwarfs Earth, roughly 10 times larger, while temperatures here soar to 11,700 degrees Celsius, more than twice the temperature of the Sun's surface. Uranus, an icy enigma. Uranus marks the beginning of our journey to the more distant reaches of the solar system. As one of the 2 ice giants, it stands out due to its peculiar rotation. It spins uniquely on its side. Each Uranian day lasts around 17 Earth hours, which is comparatively fast. Being classified as an ice giant doesn't imply it is strictly composed of ice. Rather, it predominantly contains heavier elements, excluding hydrogen and helium. Upon arrival in Uranus's realm, one would first need to avoid collisions with its rings. Beyond the rings lies a toxic atmosphere where deceptive temperatures plummet below minus 220 degrees Celsius, rendering it the coldest planet in the solar system. If the frigid temperatures and toxic environment don't bring your efforts to an end, descent through Uranus's atmosphere presents even greater challenges. As one moves deeper, the atmosphere thickens, revealing ice pellets raining down in an ominous storm. In an extraordinary twist of fate, explorers may discover that this rain consists of diamonds, propelled by wind speeds of up to 900 kilometers per hour. Yet, the dangers of descent are ever present. The pressure reaches about 100 times that of Earth's. The weight of this immense pressure would ultimately crush anything that dares to venture too close. Neptune, the final frontier. Neptune, the second ice giant of our solar system, exhibits striking similarities to Uranus. Being the farthest planet from the Sun, it sits approximately 30 times farther from our star than Earth. Consequently, Neptune's atmosphere is characterized by darkness and frigid temperatures, pressuring any would-be explorer. However, while its outer layers are exceedingly cold, deep within the planet, temperatures are astonishingly high due to the intense pressure that builds toward the core. At Neptune's core, temperatures soar around an astounding 7,000 degrees Celsius, surpassing the Sun's surface temperature. Interestingly, like Uranus, Neptune is famed for its diamond rain, a phenomenon caused by the high pressures that break down methane and convert it into solid diamonds. Accompanied by some of the strongest winds recorded in the solar system, which can reach supersonic speeds, Neptune remains an unforgiving world. Thanks for watching. Click like, subscribe to the channel, and check out my other videos. There's still a lot of interesting stuff. See you later.